Network Plus course. Challenge Handshake Authentication Protocol CHAP. The Challenge Handshake Authentication Protocol is a secure authentication protocol because with CHAP the username and password never cross the wire. Instead, both the client and the server are configured with the same text phrase that's known as a shared secret. When a client sends out an authentication request, the server responds by sending a random value called a nonce plus an ID value back to the client. The client takes these two strings, sequence them with the shared secret, and then generates a one-way hash value using the MD5 message digest algorithm. MD5 encryption algorithm. This hash value is transmitted back to the server, which performs the same algorithm using the same values and shared secret. The server basically compares the hash value that it received from the client with the hash value it is calculated. So if they match, the client gets to be authenticated. I know this sounds pretty complicated, so let me give you a visual demonstration of how CHAP works in figure 1316. Okay, so number 1, log on request. 2, 3, challenge. 4, 5, encrypt response. 6, 7, authorize and fail. Compare encrypted results. MS-CHAP. Microsoft has its own variation of CHAP known as Microsoft Challenge Handshake Authentication Protocol, MS-CHAP. It works basically the same way as CHAP, except that unlike CHAP, which requires the shared secret to be stored locally in clear text, MS-CHAP encrypts the secret locally, and whereas CHAP provides authentication of the client by the server only, MS-CHAP version 2 is capable of mutual authentication so that the client can be sure that the server is legitimate as well. Also, the encryption method used to generate the one-way hash in MS-CHAP is DES, which stands for Data Encryption Standard. Finally, and predictably, MS-CHAP doesn't work on Linux or other platforms. It's a Windows proprietary protocol. Extensible Authentication Protocol, EAP. Extensible Authentication Protocol is an extension of point-to-point protocol that provides a host of additional authentication methods for remote access clients. Some examples include smart cards, certificates, Kerberos and biometric schemes like retinal scans and fingerprint and voice recognition. Although EAP itself doesn't allow for mutual authentication, enhanced forms of the protocol do. For example, EAP TLS and EAP TTLS, a tunneled version of EAP TLS, create a secure tunnel through which password-based versions like EAP and MD5 can run. Hashes. Hashing is a cryptographic process that uses an algorithm to derive a value from a set of clear text to verify that the information came from where it says and that it has not changed. Therefore, we say hashes are used to provide data integrity and origin authentication. Two of the most well-known algorithms are discussed in the following sections. MD5. MD5, the message digest algorithm, was designed by Ron Rivest, and while it has shown to have some flaws that cause many to prefer SHA described in the next section, those flaws are not considered fatal, and it is still widely used to ensure the integrity of transmission. As in the case with most hashing processes, the hash is created from the clear text and then sent along with the clear text message. At the other end, a second hash of the clear text data is created using the same algorithm, and if the two hashes match, the data is deemed to be unchanged. SHA, secure hash algorithm, is a family of algorithm versions, much like MD5, having multiple versions on its way to becoming MD5. It is published by the National Institute of Standards and Technology NIST as a US Federal Information Processing Standard, FIPS. It operates as any hash does and is considered to be superior to MD5. Network access control. Network access control systems that control access to devices based on their security settings include Cisco's Network Admission Control NAC and Microsoft's Network Policy and Access Services NPAS. These systems examine the state of a computer's operating systems updates and anti-malware updates before allowing access, and in some cases they can even remediate the devices prior to permitting access. In the following sections, key components of network access control systems are covered. Posture assessment. When devices attempt to access the network, devices are examined closely, which is called a posture assessment. The following items can be checked: anti-malware updates, operating system updates, Windows registry updates. When the assessment is complete and is positive, admission is granted. If problems are found, admission may be denied and the user notified that action must be taken, or the device may be directed to a remediation server that can install missing updates or quarantine the device if necessary. Guest network. When a device is attempting to connect to a network using a form of network access control, the device is first placed in a guest network until the posture assessment is performed. Until it is either approved or remediated, it will remain in the guest network. The guest network will not allow access to the balance of the network to prevent the device from introducing issues to the network. Persistent versus non-persistent agents. Network access control systems can be deployed using either persistent or non-persistent agents on the devices. A persistent agent is one that is installed on a NAC client and starts when the operating system loads. This agent provides functionality that may not be present in the non-persistent agent, such as system-wide notifications and alerts and auto and manual remediation. A non-persistent agent is one that is used to access the device only during the one-time check-in at login, usually through a captive web portal. The non-persistent or dissolvable agent is removed from the device when the authentication webpage is closed. It can be used to support the assessment of endpoints not owned by the organization, as such can help to make bring your own device BYOD policy possible. Captive portal. When a wireless network is in use, one method of securing access to the wireless LAN is using a captive portal. This is a web page to which the users are directed when they attempt to connect to the wireless LAN or WLAN. This web page may ask for network credentials, or in the case of a network guest, it may only ask for agreement to the usage policy of the network guest. Quarantine network. When a guest machine is found to be out of compliance with the security posture required by NAC system, the device is placed in a quarantine network. which prevents the device from exposing the rest of the network to the security risks that have been identified by the posture assessment. It will remain in this quarantine network until it is able to pass the assessment. In cases where the NAC system supports remediation, the device may be connected to a remediation server that can make the required changes or updates to the system. Once the remediation is complete, the device is able to pass the assessment. It is then allowed to proceed onto the protected network. Edge versus access control. While controlling access to the network at the edge or boundary of the network, typically using firewalls, is certainly a proven method of protecting a network, it is somewhat of a blunt instrument of access control. Certainly the use of certain protocols and services can be prevented, and firewalls can even be granular enough to single out IP addresses and subnets, but at some point more sophisticated means of control are indicated. Access controls that are applied where the resource resides often can be much more granular and can be more easily placed under the control of a resource owner. It is also less likely that mistakes in the application of access control lists on the resources will cause the type of widespread access problems that mistakes in ACLs and firewalls may have. In today's network, there is a place for both access and edge control. Understanding the role of each can play, and properly utilizing them can result in a layered approach to network security. Summary. In this chapter you learned about the two most basic security concerns: security filtering and user authentication. First, we talked about how to allow remote computers to join your network and how to specify the way traffic leaves your network using access control lists. Then you learned about the various tunneling and encryption protocols like SSL, VPN, Layer 2 tunneling protocol, point-to-point tunneling protocol, and IPsec. Moving on, we examined several of the ways used today to remotely access networks, including RAS, RDP, PPP, PPPoE, and ICA, where we wrapped things up by discussing solid user account and password management policies and why those policies are essential to maintaining tight security on your network. Finally, you learned about authentication methods like PKI, Kerberos, Radius, TACAX Plus, 802.1x, CHAP, MS-CHAP, and EAP. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.